Welcome to Pharma A1 YouTube channel. I would like to explain about how to learn chemical structures in medicinal chemistry. First point, study basics of chemistry, then heterocyclic compounds, then understand basics of chemical structures, then practice chemical structures daily. Now I would like to explain first point, study basics of chemistry. We can study basics of chemistry in Arun, Bahl or Morrison and Bahl. These are two textbooks. You can study from these. Then next point, study heterocyclic compounds. After studying basics of chemistry, you have to study all heterocyclic compounds. You have to practice all heterocyclic compounds. Now I would like to explain in detail. In heterocyclic compounds, so many types are there. First one is 3-membered ring, 4-membered ring, 5-membered ring, 6-membered rings, 7-membered ring, 8-membered ring, 9-membered ring. 3-membered heterocyclic ring. First one, aziridine. Numbering start from heteroatom 1, 2, 3. Then second, oxyrane, thyrane. You can see here Aza group is there. You can remember like the aziridine, oxyrane, oxygen, oxyrane, thyrane. Okay. Next, 4-membered heterocyclic rings. 4-membered heterocyclic rings. First one in azitidine. Azitidine. Okay. Numbering here also start from heteroatom. Okay. Start 4-membered ring. Okay. Azitidine. Dihydroazetine. This is dihydroazetine. Oxetine. 1,3-diazetidine. Oxetine. In name itself, you can by using name itself you can write the heterocyclic ring. Oxetine, thioetine, acetidine, 2-one. Beta lactam. This is beta lactam ring. Very important. This is this ring. 5-membered heterocyclic rings. First one, pyrrolidine. Numbering start from heteroatom. Pyrrolidine. Okay, without double bond. This is pyrrolidine. Okay. Pyrroline, 1 double bond. Actually there will be 2 double bond with lone pair of electron. Okay, only 1 double bond, pyrrolidine. You can see here, this is pyrrole. Okay, there is a lone pair of electrons also. It's involved in aromatic city. Pyrrole, just compare pyrrole, pyrrolidine. Pyrrole with double bond, pyrrolidine without double bond. Next, pyrazole. You can see here, pyrrolidine, pyrazolidine. This is pyrazolidine. Just one more amine you have to add, aza. You can see here, pyrazolidine. Just this is pyrazolidine. Imidazolidine. Difference between imidazole and imidazolidine is, I will write here. You can see here. This is imidazole. This is imidazole. This is imidazole. This is imidazolidine. The difference between these imidazolidine and imidazole is only double bond. Imidazole contain double bond. This is imidazolidine without double bond. Okay, you can remember like this. You should remember. This is tetrahydrofuran. In short way, THF. Tetrahydrofuran. This is furan. THF without double bond. This furan with double bond. Okay, furan, oxygen. You can remember like this. Dioxolane. Okay, dioxolane, 2 oxygen. Tetrahydrothiophene. This is tetrahydrofuran. This is tetrahydrothiophene. Okay, this is thiophene. Tetrahydrothiophene. You can see the difference. Oxazole, you can see here, oxa group, azole group here. You can remember like this, oxazole, isoxazole. The difference between oxazole and isoxazole is, you can see here, if you numbering this, numbering start from heteroatom 1, 2, 3, 4. The nitrogen shifted to second position, then you have to tell is isoxazole. This topic, if you want to know more detail, you read isomers. Coming to next, sulfolane. You can see this is sulfolane. This is sulfa group. This will come when you are studying about sulfonamide. These groups will come thiazolidine dienone. You can see thiazolidine dienone. Succinamides, oxazolidine on. Hidden when you are studying about anti-epileptic drugs, there you will see in phenotine. The phenotine is a drug which is used to treat epilepsy. There you will come, there you can see hidden toin. How to write is just write imidazolidine. With that, second and fifth position ketone group. Coming to continuation of 5-membered heterocyclic rings. First structure pyrazoline, 5-membered ring. Imidazoline. Okay, imidazole. How to remember imidazoline? Just remember only one. There is a in imidazole there is a 2 double bond. Here only 1 double bond. Okay, pyrazole. This is pyrazole. Imidazole. How to remember imidazole? Just remember 1 and 3rd position there is a amine group. 1 and 3rd position I have to write amine group. This is a 5-membered ring. Okay, when you if you know when you numbering, when you do numbering 1 and 3rd position, if there is a amine group, then it consider as imidazole. Then triazole. You can see these both are triazole. The difference is the position. 1 to 4 triazole. This is 1 2 3 triazole. Okay, tri 3 aza means nitrogen. Triazole you can see here. Next, coming to tetrazole, 4 azoles are there. Okay, coming to here isothiazole. Okay, iso, as I told, if there is a if they change the position, then it will become iso. Okay, one position to next position, then it become isothiazole. Okay, oxathiazolin, oxathiolane, oxadiazole, thiadiazole. Can see here these 3 are oxalane. These 2 are same. These 2 are same. The difference is the position. Next slide. Sulfolane, thiazolidine dione, succinimides, oxazolidine on, hidden toins, thiadiazole. Okay, hidden toins. When you study anti-epileptic drugs, in that one drug will come, that is phenytoin. The phenytoin basic moiety is hedentoin. Phenytoin used to treat epilepsy. The basic moiety is hedentoin. There you can study. If you know the hedentoin, it is easy to learn, easy to practice, easy to learn phenytoin structure. So that's why I'm telling you should know the all heterocyclic compounds. Coming to next slide. 6-membered heterocyclic rings. First one, this is very very important, pyridine. You can see here pyridine. Okay, without pyridine, pyridine. You can see that. Just see, study by comparing with the 2 structure. If there is a similar structure, if there is a, you can see this is, these both are similar structure. This is pyridine, this is pyridine. If you see the structure, the in pyridine double bond is there, in pyridine there is no double bond. Just like that, you compare by comparing the structure. If you study, then you will feel in less time you can study more. You can see here, this is pyridine, this is pyridine. Okay, the difference, you know, pyridine without double bond, pyridine with double bond. This pyrazine, you can see here there is no azine in this pyridine. There is no azine. You can see here this is azine, means one more amine group is there. This is pyrazine. Next, pyridazine. Okay, this is pyridazine. You can see this structure. Pyrimidine. You can, you know, in 5-membered ring we write imidazole. Like that, this is 6-membered ring. Like that only, this is pyrimidine. This is also 1/3 position amine group, pyrimidine. Okay, thiane. This is thiane. Thiopyrene. This is dithiane. Dithiothiane. Coming light. Continuation of 6-membered heterocyclic ring. Pyrazine, very very important. Pyrazine, how to write? 1/4 position. There is an amine group. Pyrazine. Triazine. This is triazine. Tri means 3 aza groups. 135 triazine. Tetrahydropyrene. This is tetrahydro. You can remember tetrahydro. THP. You can remember like the tetrahydropyrene. Coming to next, trithiane. Morpholine. You can see this is morpholine. Okay, morpholine, how to write? Pyrene, pyridine. Combination, both combination also you can remember like morpholine. Okay, oxazine. The both are similar structure. Difference is double bond. Okay, you can see 1 2 same. The difference is double bond. Coming to next, pyrene. This is pyrene. Pyrrolum, dioxane, dioxane. Because of double bond, this is oxane. You can see here. Oxazine. This is oxazine. Both are same structure. The difference, both are similar structure. This and this. The difference is double bond position. Oxazine. Next, thiomorpholine. This is very very important. Remember this thiomorpholine. Okay, you can see a thio group, sulfur, morpholine. As you write morpholine, when you write morpholine structure, I will show you. This is morpholine structure. This is morpholine. Instead of here oxygen, just if you write here sulfur, then it will become thiomorpholine. Coming to next, thiazine. You can see thiazine. You should know the numbering. Numbering should start from heteroatom. Okay, this is 6-membered, no? So I did a 6-membered. Okay, thiazine. Coming to next, 7-membered heterocyclic rings. First structure, indene. Okay, indene. ENE. You can represent double bond. There is a presence of double bond. You can see here. Indoline. Without double bond, indoline in this structure. Indole. What is indole? Indole, how to remember indole? Indole, just benzene fused with pyrrole. You know no pyrrole? I will show you pyrrole. As you already seen previous slide, pyrrole. This is pyrrole fused with benzene. Okay, just fused with benzene, it will become indole. You can see both are same structures. Okay, just remember indole. How to remember indole? Benzene fused with pyrrole. Then it will become indole. Okay, then coming isoindole, as I told iso, there is a shifting of this amine group here, then it will come iso. If you read isomer, you will come to know why we call it iso. Okay, just read that's why I told in beginning you should know the basics of chemistry. Basics, whatever the basics are there, you should know. 7-membered heterocyclic ring. Continuation, azaindazole. This is purine. When you are studying about nucleic acids in this DNA, RNA, in that adenine guanine, the adenine guanine basic moiety is purine. So you should know the purine. How to remember purine structure is for that, whatever I told in previous slides, the two heteroatom you have to remember. One heteroatom, this heteroatom name is pyrimidine. This is imidazole. This both, if you remember, this is pyrimidine, imidazole. Both are fused, it will become purine. Just remember both, you will come to know. Then coming to next, benzofuran, benzene, okay. Then furan, we can see here, benzene, then this is furan. Then isobenzofuran, as I told iso in previous slides, about iso and all I told. Then coming to here, benzothiophene, this is thiophene, benzo, you can see it, benzothiophene, okay, benzothiophene. Coming to next slide, benzothiophene, both are same, the small difference is the double bond, that's all, the shifting, that's all. Coming to next slide, benzoisoxazole, you can see here, benzo, this is benzene, isoxazole, as I told previous slides, isoxazole, the both are fused, it will become benzoisoxazole. Next, anthranil, this is anthranil, this is isothiazole, isothiazole, thia group, azole, okay, thiazole, this is thiazole fused with to benzene, so it will become isothiazole. Coming, this is same structure, just the small change is shifting of double bond. This is benzoxazole, benzthiazole, this is benzothiadiazole, you can see this is benzo, this is benzene, thia group, dia, two aza groups are there, so thiadiazole. Coming to next slide, furopyrrole, see, this is furan, this is, you know, already this is pyrrole, this is furan, both are fused, it become furopyrrole. This is thine pyrrole, thiophene and pyrrole, both are fused, it will become thine pyrrole. Coming to next, thine pyrrole, same, both same. Indolizine, this is indolizine, you can see indazole, this is like indole, related to indole class. There, when like this structure will come, remember indole, okay, 5 member, 6 member fused with 5 member, just remember like indole classes, okay, indole. And then you can see, remember benzofuran, benzothiophene also, benzimidazole, this is benzene imidazole, this is then benzimidazole, just fused, these are both fused, that's all. Aza indole, you can see aza, this is aza indole, it's like indole, just they kept this aza group at 7 members. You can remember, you can numbering indo, this is indole structure only, this is basic indole, this is not indole structure, this is aza indole. Now you can number, this is 1 2 3, can numbering this, you can see here 7 position they kept aza, so it is indole. If you for indole, if you write aza group at 7 position, it will become 7 aza indole 4 aza, just amine group here at 4th position, aza indole 5, like that 6, same, just the small difference is the position, amine group position. Coming to next slide, 8 membered heterocyclic rings, 8 membered heterocyclic ring, decahydroisoquinoline, this is decahydroisoquinoline, decahydroquinoline, tetrahydroquinoline, you can see tetrahydro, because of this there is no double bond, so the way we written this is a tetrahydroquinoline, here dihydroquinoline, okay, dihydro. And you should know the numbering, okay, you can numbering from heteroatom, that's all, nothing is there more. Dihydroisoquinoline, you can see iso, because shifting here, okay, so it will come isomers, okay. Then inoxazoline, thalin, sorry, thalazine, this is thalazine, quinazolin, this is quinazolin, sinolin, this is sinolin, naphthyridine, this is naphthyridine, you can see here, this is naphthyridine, the fused of 2 pyridine, if you fuse 2 pyridine, it will become naphthyridine. Sinolin, just pyrazine and pyridine fuse. 8 membered heterocyclic rings, first one benzoxazine, then quinoline 1, isoquinoline 1, phenoxazine, you can see phenoxazine, oxazine, oxazine, phenothiazine. This phenothiazine, 2 benzene fused with, this is thiomorpholin. You know morpholin structure, as I told in previous slide, I told morpholin structure. This is morpholin. Okay, this is morpholin. Just you have to replace this oxygen with sulfur. Replace this oxygen with sulfur, it will become thiomorpholin. This thiomorpholin fused with 2 benzene, it will become phenothiazine. It will become phenothiazine. Then coming to next, phenoxathin. Phenoxathin, right? Chromin, this is chromin. Isochromin, just iso. Chromin 2 on benzooxazine, fluorine, carbazole, dibenzofuran. These are all very important. Carbazole. Okay, this is benzene fused with pyrrolidine. You can see this is not pyrrole, this is pyrrolidine. Pyrrolidine means, as I told, without double bond. Pyrrole with double bond. This is pyrrole. This is pyrrolidine. Pyrrolidine fused with 2 benzene. Then acridine. Acridine is very important. Just write pyridine fused with 2 benzene ring. Phenazine. This is phenazine. Next, quinoline. Very important. Quinoline drug. This come when you are studying about anti-malarial drugs. When you are in that 4 aminoquinolines, 8 aminoquinolines, basic drug is quinoline. You should know this. Benzene fused with pyridine, it will become quinoline. Then you can see here isoquinoline. Just transfer here nitrogen. This group, nitrogen group, it will become isoquinoline. Okay, quinolisine. This is quinolisine. You can see here pyridone, pyrimidine, pyridopyrimidine, pyridine. This is pyridine. This is pyrimidine. It will become pyridopyrimidine. Pyridopyrazine. This is pyrazine. This is pyridine. Pyridopyrazine. Pyridine. This is very important. When you are reading about sulfonamides, there you will study about this structure. Pyridine. There you will see this structure. Pyridine. Should know. Next slide. Next point. Understand basic moiety of chemical structures. You have to understand the basic moiety which is present in chemical structures. I took 2 examples, chlorpromazine, triflupromazine. These both drugs come under antipsychotic drugs. These both drugs are antipsychotic drugs. Okay, both are antipsychotic drugs. In medicinal chemistry, when you see any chemical structures, first you have to understand basic moiety of that chemical structures. I took here chlorpromazine, okay, as an example. You can see in chlorpromazine the basic structure is, you can see this is the basic structure, phenothiazine. This is the phenothiazine. This is the basic structure of this structure. Okay, you can see, first you have to understand. That's why I in beginning slides only explained about heterocyclic compounds. If you know heterocyclic compound, you can easily understand the basic moiety which is present in chemical structures. You should know heterocyclic compound. I explained about phenothiazine in early slides. So you can see here chlorpromazine. In triflupromazine also basic structure is chlorpromazine. Okay, after understanding the basic structure, then you have to put the numbering, or before after understanding basic structure, now this is phenothiazine. The numbering should be start from here. Okay, numbering start from here. You can see numbering. Okay, after that you can come how to remember structure. Okay, you can see this both structures. After understanding basic moiety, now you have to remember this attachments. Okay, this attachment, how to remember this attachment? Just remember, you can see almost all both structure are almost all same. See, when you are I will tell you one more thing. When you are studying any class of drugs, if you take example of antipsychotic drugs, in antipsychotic drugs almost all drugs are, the basic moiety is phenothiazine. Almost all drugs are from phenothiazine rings. Phenothiazine, okay, phenothiazine, you just remember the phenothiazine. After that, write all drugs, and in one paper write all drugs of antipsychotic drugs. After that, compare the drugs, okay, compare the drugs. Among them you just compare, I will compare this, okay, chlorpromazine and triflupromazine. Comparison uh, between these drugs, almost all similar, almost all same, okay, you can see here almost all it is same. Here also chlor, here also phenothiazine basic moiety, here also phenothiazine beta. Only there is a small changes, you can see this is also this attachment at 10th position, propane dimethylamine, here also propane dimethylamine. How to remember this propane dimethylamine? You can see name itself, it is there, prop means propane, remember like that, propane. Dimethyl you have to remember by yourself, okay. You can see here a propane, okay, you can see here propane. Dimethyl you have to remember by dimethylamine, you have to remember yourself. After that, you can see at 8th position chlorine is there, you can see name itself, chlorpromazine. Azine means remember like there is a phenothiazine ring. Azine remember like phenothiazine ring is there. Prop means propane at 10th position, and dimethylamine, as I told, you have to remember yourself. Chloro at 8th position, just remember this, chloro at 8th position, propane is there, azine, mighty, this much enough. Then easily you can write the structure. Same thing here also, the small change, chlorpromazine triflupromazine is almost all same, only there is a change at 8th position. In chlorpromazine at 8th position, you can see here chlorine is there. In triflupromazine at 8th position, you can see at 8th position fluorine is there. In name itself, answer is the trifluo, means three fluorine groups. You can see here at 8th position 3 fluorine groups is there. That's all. It is almost it is easy. If you know the heterocyclic compounds, then easily you can understand the chemical structure, you can practice it, and you have to practice daily. Okay, coming to last point, practice chemical structures. You have to practice whatever chemical structures in your syllabus, you have to practice that. Take the white paper, write all structures, whatever you have structures, write all structures in white paper, and practice daily. If you practice, and you should follow this way whatever I told. If you follow this way, if you practice, definitely you can remember the structures for longer time. And you can, when you start writing in white paper, you can write like this. First write the basic moiety of that class. If you take, I will take example of antipsychotic, the basic moiety in this phenothiazine, then all structures, okay, you can see triflupirazine, thioridazine, chlorpromazine, promethazine, promazine, okay, all these structures like this you have to write, and you have to practice, okay, practice, you have to practice. Thank you. I hope you enjoy this video. Thank you for watching. Subscribe my channel and press the bell icon so that you will get all notifications of new videos. Thank you.